All right, we're looking at our last lesson in Chapter 3. It's a little bit fitting because if I'm thinking right, I taught you the very first lesson, 3.1, and now you get to listen to me for the video of 3.6, and Mrs. Olson did everything in between. It's not really that funny, but that just hit me. Okay, 3.6, quadratic inequalities. There are two things here that we're looking at in 3.6. I'm only going to go through one example of each of them. So I would highly recommend making sure that you get these written down, even if that means you have to pause the video, listen, pause the video, write it down, and take a little more time. Just so that you don't have to watch forever. I'm only going to go through one example of each thing. So first, after the quiz yesterday, you looked at graphing inequalities. Today we're going to look at graphing quadratic inequalities, but you're going to have a system of quadratic inequalities. So you looked at in 3.5 solving an inequality, in 3.5 you looked at solving a quadratic system. Solving a quadratic system with an equal sign just meant that you were looking for where the two parabolas overlapped. Now here in 3.6, instead of having an equal sign, we're going to have an inequality. So we're going to have to do, just like you did after the quiz yesterday, you're going to have to do some shading. So this is item number 1, first example. The second example that we'll look at is solving a quadratic inequality in one variable. Well, let's say I just gave you this. You would be able to use your quadratic formula, you'd be able to do a lot of things to try to solve this factor. But let's say I changed it to be like this. Well, now what do we do to solve? Because we don't just want everything that equals y, we want all the numbers that are less than or equal to y. So these are our two examples here, solving a system of quadratic inequalities and solving just a single quadratic inequality. Okay, example 1. Graph the system of quadratic inequalities. Now by graphing, that is how we solve. So it could say here graph, or it could say here solve. Let me just get my graph set up. Oh, that doesn't look very good. Come on, there we go. Perfect. Okay, now this is going to be in blue. So negative x squared plus 3. So I'm up 3, 1, 2, 3. And I'm going to put an open dot here because it is just greater than. It is not equal to. This is facing down. There we go. Facing down because it's negative, and I'm striping this line for the same reason that I have an open dot. Now, we have to shade, just like you shaded on the worksheet after the quiz yesterday. We've got to make sure we're shading inequalities. If I want all the y values that are greater than my parabola, everything greater would be everything that is above, or above representing the outside here. Now, I'm going to go through and on the same, on the same graph, I'm going to graph x squared plus 2x minus 3. I plugged that into my calculator because I couldn't remember what it looked like. And it looks like I've got my vertex at negative 1, 2. This is going to be a closed dot because we are equal to. My parabola looks something like this. Like that. I'm not looking for like point for point perfect on these. I'm looking for a rough sketch here. Now when I shade, again, I'm going to go to my vertex and it says I want everything greater than. Well, everything greater than my vertex would be everything on the inside. Here's where I'm going to shade. Like this. Now, what this shows, remember I said we could say that this means to graph or solve the quadratic inequalities, the system. Any point that is here in this double shaded area would be considered to be part of my solution. So if I asked you to list a solution, then I could choose any point in this area, and that would be a solution to both of the inequalities. All right, then the second thing that we need to look at is solving this quadratic inequality. It says algebraically. We're not going to look at a second. There's another way we could solve this by graphing. We're not going to look at this. We're just going to solve it by hand. We would also call this using the test point method. So solving algebraically, the only way we're going to look at, or solving using the test point method would be the same thing. Now, to start out, I'm going to solve this just like I would if this were an equal sign. So it's set equal to, or zero's the only thing on this right-hand side, and that's my first step. Next, I could use any of my methods to solve this: quadratic formula, factor, graph, whatever. I like factoring. I'm good at factoring, so I like to factor. So I'm going to think about what can I multiply to get negative 32 and add to get 4. And I'm pretty sure that that's positive 8 and negative 4. Yeah, that sounds good. So that tells me then, if this were an equal sign, my two solutions would be negative 8 and positive 4. Now, this is not an equal sign, so we can't just stop there. What we're going to do next is put these two things on a number line: 0, negative 1, 2, 3, 4, 5, 6, 7, 8. And at negative 8, I'm going to put a filled in dot because it's equal to. If it were just greater than, it would be an open dot. And then also at 4, I'm going to put a filled in dot. I know that these two numbers, negative 8 and 4, if I plug them into my inequality, they would be greater than or equal to 0. Actually be equal to 0. Now, what I need to figure out is, are the rest of my solutions, these aren't the only two, are the rest of my solutions all the numbers in between here, or all the numbers on the outsides of each one of them? It's going to be one of those two things. We're not going to have a situation where it's like this, okay? It's either going to be in between or outside. So what I'm going to do is I'm going to test a point. I'm going to take 0 is the easiest one. I'm going to take 0 and plug it in. 0 squared plus 4 times 0 minus 32 is greater than or equal to 0. This would give me negative 32 is greater than or equal to 0. Now, negative 32 is greater than or equal to 0. This is not true. Oh, not x. This is where we do our stat face. Sorry. Whoop. This is not true. So that tells me that all of these numbers in the middle are not a solution. No. So what that does mean then is all the numbers on the outsides would be our solutions. I would take your answer as being this number line right here. If it were a multiple choice question, I might also have an option that says x is less than or equal to negative 8 here, and x is greater than or equal to 4 here. So if you want to write it this way, you can. On the test, I give you a number line, so you could just put it on the number line and be done. Or again, you could go one step further and write the actual inequality. If you wanted to check your answer one more time, you could take a number that's here, maybe like 5 or 10 or something easy. You could plug it in for x, and it should work. It should make the inequality true. Okay? So we solve, our steps here are solve. Well, first we have to make sure 0 is on a side by itself. But then we solve just like we would if it were an equal sign. We take our solutions and we put them on the number line. And then we have to test a point on our number line. I would recommend 0. If it works, then that means our solutions are everything in between. If it does not work, our solutions are everything on the outside. So then we have to draw our, that would be step 4. We have to draw our arrows then. Okay, those are your two things. Shading, solving a system of quadratic inequalities. Shading, the double shaded, is where our solutions are. And then solving just one quadratic inequality.